Hello again. In this video, I'm going to go over this homework problem from chapter 3. And so in this problem, we're supposed to find the derivative of this function, 2x squared minus 6x plus 5. And then we're supposed to find an equation of the line tangent to the graph of the function at a comma f of a, where a is equal to 1. So let's find the derivative first. And we're going to find the derivative using the limit definition of the derivative, which is this formula here. And I'm going to do this in pieces. So the first thing I'm going to do here is I'm going to find f evaluated at x plus h. Okay, so f evaluated at x plus h. What this means is you have to input x plus h into the function, right? This is your input. And then you have to determine what comes out when you put that in. Now notice anything you put into this function, what the function does to that input is it squares it first, and then it multiplies that by 2, and then it subtracts 6 times whatever you put into the function, and then it adds 5. So if you put x plus h into this function, what's it going to do to it? Well, it's going to take it and square it first, and then it's going to multiply that by 2, and then it's going to subtract 6 times whatever you put into it, which is x plus h, and then it's going to add 5 to that. So if you put x plus h into this function, this is what's going to come out. This is the output. Now, we're going to have to FOIL this out, so I'm going to do that on the side. So x plus h times x plus h. So first would be x times x, which is x squared, and then the outer would be x times h, and then the inner would be h times x, which is the same as x times h. The order in which you multiply doesn't matter, so I'm going to write h times x. I'm going to rewrite the order and write it as x times h. They're the same thing. The order doesn't matter when you multiply. And then the last would be h times h, which is h squared. Okay, so then down here, that's what you get when you FOIL this out, okay? And then we got to multiply that by 2. And then I'm going to go ahead and write this. You have x times h plus x times h. That's really 2xh. Okay, and then I'm going to distribute the negative 6. So you get negative 6x minus 6h, and then plus the 5. Okay, and then let me distribute that 2 to all 3 terms. So you get 2x squared, and then 4xh plus 2h squared, and then minus 6x minus 6h plus 5. Okay, so that's f evaluated at x plus h. Now, if you go back to the original formula, then after that, you have to subtract f of x off. Okay, and so what I'm going to do is I'm just going to erase this equal sign. This is f evaluated at x plus h. So I'm going to go back to this original formula. That's this first piece right here. And then I'm going to subtract f of x off of that. So minus f of x. Okay, but f of x is simply 2x squared minus 6x plus 5. Okay, and then all of that is divided by h. Okay. So then I'm just going to clean this up. We have to distribute this minus sign. So you get everything in front Let me just rewrite all that down. 2x squared plus 4xh plus 2h squared minus 6x minus 6h plus 5. And let me move this h so it doesn't get in the way. Okay, and then distribute this minus sign. So you get minus 2x squared, and then a minus times a minus is a plus, so it's plus 6x, and then minus 5. Okay, and then all of that is divided by the h on the bottom. Now, let's see if we can't clean this up. Notice you have a 2x squared in front. That cancels with the minus 2x squared over here, so this cancels with the very first term here. And then the 6x, the minus 6x here, cancels with the positive 6x here. And then this positive 5 here cancels with this negative 5 here. Now, you should take note of this. This is the f of x part right here. The stuff in the brackets. Every one of those terms should cancel out if this is going to work. And in this case, they did. So you should always check to make sure every one of those terms cancels out with terms from the f of x plus h piece, right, which is right here. Okay, the first 6 terms in front came from f evaluated at x plus h. So those terms, some of those terms should cancel out all of the terms that you have from f of x. And notice what you're left with. So let's write this out. You're left with 4xh plus 2h squared minus 6h, and then that's divided by h. Now notice every one of the terms on top has an h in it. Okay, and because of that, you can cancel with the h in the bottom. In fact, this h on the bottom divides all 3 of these terms, right? That's the reason this division sign goes all the way across. So for example, the very first term, this h cancels with the h on the bottom, leaving you with 4x. But then this h on the bottom also cancels with one of the h's for the second term, leaving you with 2h. And then the last term, those h's cancel as well, and you're left with a minus 6. Okay? And now, just to finish this off, to find the derivative of this function, we have to find the limit of that as h goes to 0. Now don't forget, if you go back and look at the original formula for the derivative, right, the limit definition, you do have to find the limit as h goes to 0. Okay, so what I just found was f of x plus h minus f of x divided by h, and now we're finding the limit of that as h goes to 0. Okay, so down here, if h is heading towards 0, you can use substitution to evaluate this limit, right? As h gets closer and closer to 0, this term right here, 2h, that gets closer to 0. And so this entire thing is going to get closer to 4x minus 6. Now notice, h is heading towards 0, not x. So when you evaluate this using substitution, you want to substitute the 0 in only for the h and not for the x. And so for that reason, as h gets closer and closer to 0, this term right here in the middle goes to 0, and the entire thing gets closer to 4x minus 6. And that's the derivative of the original function. Okay? All right, so that's part A. Now let me scroll down. Actually, I'm going to erase, because I'm running out of room, I'm going to erase some of this. Or maybe I'll just go to another page. Okay, so now let's, part B. Now you have to find the equation of the tangent line at a comma f of a, where a is equal to 1. Okay, so to find that, first of all, the equation of a line, the one that we're going to use, is y minus y1, or y minus y1 is equal to m times x minus x1. And that's called the point slope formula for the line. And so what we have to fill in here is we have to fill in the slope, which is m, and then a point on the line, right? The slope of the line and some point x1 comma y1 that is on the line. Okay, so the slope of this line, the slope of the tangent line, is the derivative at the point a equal to 1. Okay, so from the part A, we found the derivative of this function to be 4x minus 6. Now the derivative gives you the slope of the tangent line at any point x. And we want the slope of the tangent line when x is 1. So you have to evaluate the derivative at 1. Okay, and when you evaluate the derivative at 1, you get negative 2. Okay, so that's the slope of the tangent line when x is 1. Okay, and now the other thing we have to find is a point on the line x1, y1. Well, we know the x value is 1 because they tell us to evaluate the tangent line when a is 1, but we don't know the y value. Okay, so to find the y value, we're just going to plug 1 into the function. So we're going to find f evaluated at 1. And so when you plug a 1 into the function, you get 1 squared times 2 minus 6 times 1 plus 5. And that gives you 2 minus 6 plus 5, which is 1. So that's the point on the line that we know. When we plug a 1 in for x, we get a 1 out for y. That's your x1, y1. Okay, so going back up here, back to the equation of the line, we're just going to plug all that information in. So y minus y1, and then m is negative 2, and then x minus x1. Okay, and then x1 and y1 are both 1. So 1 and 1. Okay, and then I'm just going to clean this up a little bit. Let's solve for the y value here. So I'm going to distribute the minus 2, and you get negative 2x plus 2. And then I'm just going to add this 1 to the other side, and you get negative 2x plus 3. Okay, and so that's the equation of the tangent line to this function right at the point when x is equal to 1. Okay, so I hope you found this video helpful, and I'll continue to work out some problems in Chapter 3, and hopefully you'll have a chance to look at some of those videos as well. Okay, bye-bye.